morning and welcome to Thursday's Maths. Now our warm-up for today is called percentage chains, and it's all about finding percentages the easy way. So using what you know. The three things you need to be able to do is to find 10%, 50%, and 1%. And if you can find out those three percentages, you can use them to work out all of the other percentages. So, to find 10%, you simply divide by 10. Divide by 10, so that would equal 24. To find 50%, you simply halve it or divide by 2. So for this case here, that would be 120. And to find 1%, you need to divide by 100. Okay, so if we move back 2 decimal places, this will bring us back to 2.4. So just remember, 10% divide by 10, 1% divide by 100. 1% is going to be 10 times smaller than 10%. So, you need a pen and a piece of paper. I'm going to put a number in the middle here. Okay, and the first three percentages, or the basic percentages you need to find are the 10%, the 50% and the 1%. And once you've found those, you can use your answers, to work out all the other percentages. When you get to 90%, you'll be able to use 50% and 40%, 95, 90 and 5%, 99%, you'll be able to use 90%, and if you know 1%, you can multiply that by 9. So your number to start in the middle is 440. Stop the tape and see if you can complete the percentage chain. Let's see how you did. Now, I always start with 10%. You can work out a lot if you know 10%. 10% divided by 10 would be 44. From that, I can find out 5% because it's half of 10%. That would be 22. If I go back to my 10%, I just double it to find 20%. That would be 88. And again, I can double that to get to 40%, which would be 176. Now to get 30%, I'm going to add 10% and 20%, which comes to 132. Moving round, I have 50% here. I just simply need to halve 440. Get 220, and if I want 25%, that's going to be half of 50%, which will be 110. Over to 1%, so I need to divide 440 by 100, which brings me to 4.4. I know 1%, I just need to double it to make 2%. That would be 8.8. Now for 90%, I've added 40% and 50%, and I got 396, and to 90% I needed to add 5%, which brings me to 95%, which is 418. And finally, 99%, you could do 100%, subtract 1%, or you could do 90%, then 1% times 9, which is what I did, and I got 435.6. To start today's lesson, I'd like you to have a look at the two pictures on the screen and tell me what you think is the same about them and what's different. Well, you've probably spotted that the shape on the left is a 2D shape. Now 2D means it only has 2 dimensions, so it has a width and a length, width and length. Whereas the shape on the right is a 3D shape. It has a width, it has a length, and it also has a depth. Let's have a look a bit more closely at a 3D shape. So let's have a look at a real life 3D shape. So here I have a lovely box that actually came at Christmas. It had a present inside it. Now, when we're discussing 3D shapes, we can use lots of vocabulary, but 3 of the words we do use are vertices, edges and faces. So the vertices are the corners here. So I can see on this shape, because it's a hexagon, will be 6 vertices on that side and another 6 on that side. So I can say this box has 12 vertices. The next thing I'm going to have a look at are the faces. And when I'm talking about the flat faces on this shape, so I've got a flat hexagonal face that side and a matching flat hexagonal face on that side. And then on the edges here, I've got flat rectangular faces. Now it's a hexagon, so there are going to be 6 of the rectangular faces and 2 hexagonal faces. So I know 6 add 2 is 8. I can say this box has 8 flat faces. And the last thing that the last vocabulary I could use to describe this shape are the edges. And this is where the flat faces meet. So if I look at the top, again, I know it's a hexagon. 1, 2, 3, 4, 5, 6 edges there. I'll turn the box over and there's 1, 2, 3, 4, 5, 6 edges there. 2 times 6 is 12, so 12 edges so far, but I've also got the edges where the rectangular faces meet. 1, 2, 3, 4, 5, 6. 12 add 6 is 18. So this 3D shape has 12 vertices, 18 edges, and 8 faces. Now here's a recap from some work we did I think last Wednesday. How many vertices, edges and faces does a cuboid or a cube have? And they have the same number of vertices, edges and faces. And then when you've worked that out, can you tell me what's the difference between them? Stop the tape and jot this down on your paper. They both have 8 vertices, 6 faces and 12 edges. The cube has square faces and the cuboid has rectangular faces. The next 3D shape that we're going to look at is the pyramid. And here are some pyramid shapes in the real world. You've got the pyramids in Egypt, which were used to bury the pharaohs and the kings of ancient Egypt many thousands of years ago. At the bottom here, this beautiful glass pyramid can be found on the outside of an art gallery called the Louvre in Paris. And here we have a pyramid-shaped tent. Now, I've got a row of pyramids here. Have a good look at them. Can you tell me what is different about each of these pyramids? What I'd like you to do is to stop the video and draw the 2D shape that is on the base of each pyramid. Now pyramids are named after the 2D shape on their base. So right at the very end we have a triangular pyramid because the base is a triangle, then a square pyramid, a rectangular pyramid, a pentagonal pyramid, a hexagonal pyramid and an octagonal pyramid. The next 3D shape we're going to look at is a cylinder. As you can see here, it's a very common shape in the real world. Now, the question I'm going to ask is, how many faces does a cylinder have? And in the context of this lesson, the faces on a shape can be flat or they can be curved. Have a little think. Well, a cylinder has three faces. It has a flat face at the top and a flat face at the bottom, which are circles, and then it has one curved face along the edges there. So 3 faces, 2 flat and 1 curved. Now let's look at a sphere. Again, a very common shape in the real world. I've got some Maltesers here. It could be a piece of fruit like an orange. It could be a ball of some sort. What can you tell me about a sphere? Well, a sphere has one curved face and it's perfectly symmetrical. Now, our next 3D shape is a prism, and I've got examples along the bottom here of several prisms. What feature makes these shapes prisms? Stop the video and have a think. So, a prism is a 3D solid with identical ends, and that means that the ends are exactly the same size and exactly the same shape. So here in this triangular pyramid, we have a triangle at this end, and at the other end will be an identical shaped triangle, the same size and the same shape. The shape on the end of a prism gives the prism its name. So because the 2D shape here is a triangle, this would be a triangular prism. So, let's have a look at some real life prisms. For the purposes of maths, I would like you to imagine that my bread here is an exact rectangle. So I have a rectangular prism. And what I want to show you is that if you took a slice through my rectangular prism anywhere, the end face would always be the same shape and size. So if I sliced it here, the face will be the same shape and size as the face at the end. If I sliced it here, the face will be the same shape and size as the end face. And that goes wherever you slice a prism, the end face must remain the same shape and size. Now here we have another prism. We certainly couldn't have a 3D maths lesson in primary school without buying a Toblerone. So as you can see, the 2D shape on the end are triangles, which make it a triangular prism. Now rather handily, I'm provided with a little pull-off tab, which enables me to take the Toblerone out inside. But straight away you can see where this prism has been sliced, you have a triangle that is identical in shape and size to the triangle that's on the end of the Toblerone, and that's what makes this a prism. Can you draw the shape, the 2D shape, on the ends of each of these prisms and then name the prism using the 2D shape that you've identified on the ends? How did you do? So we've got a triangular prism, a square prism, a rectangular prism, a pentagonal prism, a hexagonal prism, and an octagonal prism. Here are some prisms in real life. And as we've just discussed, if you cut this box anywhere along its length, the end face would always be a rectangle. Similarly, this tent is a triangular prism. The dice are a square prism. The Toblerone is another triangular prism. And the Quality Street box is an octagonal prism. If you sliced it anywhere along its height, the end face would always be an octagon. Right, a little question here. Which of these 3D shapes is a prism, and how do you know? Stop the tape and see if you can write down maybe one fact or two facts that tells you which shape is a prism. You may well have noticed that the shape on the left is the prism. It's a pentagonal prism because the 2D shape on each end is a pentagon. Now, if you sliced that prism anywhere along its depth, you would find an identical pentagon in shape and size. The reason this pyramid is not a prism, because although it has a pentagonal base, if I cut the pyramid along its height, I would get a pentagon, but the pentagon would get smaller as I got further and nearer towards the vertices at the top. Now, what I'd like you to do is to head over to Google Classroom, where you will find some activities that will help you to practice today's knowledge.